students, in this part we will be going to study about communication channel. What is communication channel and how and propagation of wave takes place through communication channel. There are basically three types of wave propagation. Okay, so we will be studying in detail about these different types of wave propagation in this part. So let's proceed. Hello students, in this part we are going to study about communication channels. Right, so let us start with the communication channels. What are the types of communication channels? First of all, if you see, broadly speaking, there are two types of communication channel. One is the wireline and other is the wireless, or we say it as a radio. Right, in case of wireless, if we see, the examples are twisted pair, cable, waveguides and fiber optics. Right, wireline basically means it has a physical medium, right? Physical medium. Okay, examples are twisted pair, cable, wave optics, waveguides and fiber optics. So in this, these are the mediums or the channel in which our information is transmitted from transmitter towards the receiver. Right, now if you see, they are arranged in the order of increasing bandwidth. That means the bandwidth or the capacity will be higher or will be maximum for the fiber optics. It will be less as compared to fiber optics. So the bandwidth will be less for waveguide as compared to fiber optics. Okay, and the bandwidth will be least for the twisted pair. Bandwidth of the cable will be lying in between twisted pair and the waveguides. So this is, they are arranged in the increasing order of the bandwidth. So bandwidth we can also say as a capacity. So the capacity will be maximum for the fiber optics. Capacity based I mean that means that the capacity is basically the rate of transmission. So rate of transmission will be maximum in case of fiber optics and it will be least in case of the twisted pair. Okay, now in case of wireless or radio, the transmission of electromagnetic waves from antenna to antenna. That means here in this case we are not having a wireline medium, right? So we will be having two antennas. Okay, one will be called as a transmitter and one will be called as a receiver, right? And we will be sending our information in the form of electromagnetic waves. So here the signal will be in the form of electromagnetic waves transmitted from transmitter towards the receiver, right? And this ranges from the kilohertz to the ultraviolet range. So the range depends, so it varies from the kilohertz to the ultraviolet range, right? Now propagation characteristics vary with frequency. The propagation depends upon the frequency, okay? And these things we will be going to see in the next slide, how the propagation changes with the frequency. First of all, let us see what are the type of waves. Okay, here we will be talking only about the wireline, wireless, that is the radio communication, in which we are not having the wired medium, right? So there can be three types of waves, electromagnetic waves. It can be a ground wave, it can be a direct wave, or it can be a sky wave. So there are three types of propagation, three types of waves which propagates in a wireless medium, right? So if you see from the figure, the ground wave basically follows the earth curvature. So if this is a transmitter and this is a receiver, so the signal will be transmitting from transmitter to receiver and it will be following the earth's curvature. So this path will be followed by the ground waves. Whereas if you see an example of direct wave, let's suppose our receiver is aeroplane. In that case, our waves will directly going towards the receiver from the transmitter. It will not be following any path or it will not be going in any other directions, right? Whereas if we see, let's suppose if we consider this is a receiver and this is a transmitter. So if we are to do the communication by using direct wave, then there will be direct line going from transmitter to receiver. Okay, but in case of ground wave, it follows the earth curvature, right? Now if you see the case of sky wave, in case of sky wave, it does not goes from the transmitter toward the receiver directly. Okay, first of all it goes in the sky, okay, and in the ionosphere region. From the ionosphere region it is refracted back, okay, towards the earth's surface, again back, and then it goes towards the receiver. Therefore they are called as a sky wave because they are refracted from the skies. Now we know that the ionosphere contains different layers, okay, F1, F2, D region, all these are different layers in the ionosphere. Okay, and the refractive index also decreases as we goes above, at the higher height in the ionosphere. Therefore, if we know that whenever the wave or a light travels from a higher denser to a lower denser medium, so it refracts back, right? Or we can say the refraction is more, the refraction angle is more. That means we can say, so therefore, and this refractive index changes, that is therefore there is a smooth bending of a light, okay, due to the different variation in the refractive index of this different layers. Okay, so if we study first of all what is ground wave, let us see the characteristics of the ground waves. So basically they operate only for the low megahertz. Okay, so basically the signals having less frequencies, okay, up to the lower range of megahertz, the ground wave propagation will take place. Okay, here the waves are guided between the earth and the ionosphere. Okay, so the waves will be guided between the earth and the ionosphere, right? And the distance of communication varies based on the wavelength. So the distance will be depending upon the wavelength, okay, or we can say on the frequency. So with the wavelength it has a direct relation. That means if we are having a signal of higher wavelength, okay, then the range will be higher. Whereas if the wavelength is lesser, then the range will also be less as compared to the higher wavelength signal. Okay, if we take an example of AM radio, okay, so AM radio, you might have heard the radio. So AM radio is right, AM radio. So it operates, the frequency is like around 1 megahertz on which it operates, and the propagation is around less than 100 miles in day but longer in night. Okay, so the distance also changes, okay, on day and night basis, because these layers also, the characteristics or the characteristics basically of the layers changes in day and night. Therefore the range also changes according to the this day and night timing, right? Now if you see the next type of wave, that is the direct wave. Now see, direct wave are also called as a line of sight, that is LOS. They are also called as a line of sight waves because they are directly going towards the receiver. They are not neither following the earth curvature nor they are going towards the sky and reflecting back from there. Therefore they are called as a line of sight or the direct wave. Okay, and the frequency range is about 30 megahertz. So about 30 megahertz the waves follows the direct wave, right, direct path. There's a need little or no obstructions, right, limited by horizon. First of all, if you see what is this little need or no obstruction, since the waves are going in the direct wave, let's suppose this is a transmitter and this is a receiver, right? So we want that there should not be any obstacle in between. Okay, so we need that there should be little or no obstructions in between. Okay, and it is limited by horizon. That means let's suppose if you consider this earth surface and this is a transmitter and this is a receiver. Okay, so the maximum distance at which it can transmit will be limited by this earth surface curvature, because if you see, the transmitter is following the wave is going towards the direct path. Okay, now let's suppose if the height is decreased, okay, height will be decreased, so then this earth surface will be acting as an obstacle in between them. Therefore they are limited, okay, by the earth's curvature also. Okay, so noise also issue. Noise actually is issues with all of the waves, right? And in gigahertz range, rain issues comes. So whenever we go in the higher range, that is under gigahertz range, so rain also causes an noise. Okay, so rain noise also get introduced. Noise due to rains, right? They are used basically for satellite and the local communications, right? Now if you see the sky wave ranges from low megahertz to 30 megahertz. Okay, signal reflects from various layers of the ionosphere, right? And this changes based on the time, frequency and the sunspots. Okay, so this characteristics of the sky wave changes, okay, depending upon the time, because we have seen the day and night, there is a difference between the day and night. Also on the frequency, that is for sure, that is for all type of waves, and also the sunspots. Okay, signals travel around the world. Let's suppose this is a earth. Okay, here is our transmitter and here is the receiver, right? So it goes on the sky, and it can comes on the other side of the our earth curvature, right? That means therefore we can say that the using sky wave the signal can travel around the world, right? Apart from this, there is one more channel, or there are different channels. So one of the channel is acoustic channel, that is a water channel, right? So acoustic means audio, or the acoustic means audio. So in case of water, I mean in the oceans, right? In the ocean, if you want to transmit a signal in the water, underground water, so we use acoustic waves to transmit from transmitter to receiver inside the water, underground water, right? So therefore there is one more channel called acoustic channels, right? Let us see an overview of the table of frequencies, right? So if you see the frequency, this is a table in which we have seen, I listed the frequency band, frequency range, and the main use. Okay, so the signal ranging from 3 kilohertz to 30 kilohertz are called as the very low frequency band. Okay, and the main use is for the long distance point to point. We know that the lesser the frequency, more the distance. Therefore the signal lying in this range, that is 3 kilohertz to 30 kilohertz, can travel at a very long distance. Okay, and therefore they are used for the long distance point to point communication. The signal or the frequency range 30 kilohertz to 300 kilohertz. Okay, so this band is called as a low frequency band, and the main use is marine and the navigational purpose, right? So now if we see from the 300 kilohertz to 3 megahertz, so this band is called as a medium frequency band. Okay, and it is used for the marine and the broadcasting purpose. Okay, again if we go from for 3 megahertz to 30 megahertz, so in case of 3 megahertz to 30 megahertz, this band is called as a high frequency band, and it is used for the broadcasting purposes, right? Now if you see the frequency range from 30 megahertz to 3 gigahertz, okay, this band is called as an ultra high frequency, that is UHF. Okay, and this is used mainly for TV broadcasting and the microwave applications. Fine. If you see the range between 3 gigahertz to 30 gigahertz, this is called as a super high frequency band, SHF, right? And this is mainly used for the radar, radio relays, and the navigational purposes. If you see the range of 30 gigahertz to 300 gigahertz, so this band is called as an extremely high frequency, EHF band, right? So the main purpose is for optical fiber communication. So these are the bands and their ranges and their applications. Okay. Now let us see bandwidth. What is mean by bandwidth? What is basically the bandwidth of a signal? Okay, so basically bandwidth is a range of frequencies. Okay, that will let's suppose if we take an example of voice signal. So voice signal basically means, let's suppose I am speaking. So so the signal basically the voice. So if you analyze the frequency range, so my voice will contain the frequencies lying between 300 hertz to 3.4 kilohertz. So all this whatever I am speaking, this all are made up of from different frequencies lying in this range. Okay, so all those the frequencies, if you will analyze the signal in the frequency spectrum, right, the frequency spectrum of this voice signal, so you will find all the signal component will lying between 300 hertz to 3.4 kilohertz. Whereas if we see audio signals, okay, in this case the music and all this also comes. So in that case the bandwidth will be lying from, or the frequency components will be lying from the range is lying between 20 hertz to 20 kilohertz. That is at the higher range as compared to the voice signal. Okay, if we see the TV signal, the signal in this case the frequency is lying from 0 to 4.5 megahertz. That is a more bandwidth, or more bandwidth is required for a TV signal, because you also know that the TV contains the picture information as well as the audio information, right? Therefore, the bandwidth requirement for TV signal is more, and it is from the 0 to 4.5 megahertz. That is, we can say that the bandwidth is around 4.5 megahertz. Data signal. For the case of data signal, it depends upon the operations. Okay, so the frequencies, the bandwidth depends on the type of operation and the application which for what the data signal is used, right? Now, if we see the bandwidth of channel, so we know that the channel can be copper cable, coaxial cable, waveguide, and optical fiber, right? So depending upon this different channels, so the bandwidth also changes. Let's suppose for a copper channel it is around kilohertz. For a coaxial cable it is around megahertz, waveguide it is gigahertz, for optical it is in the terahertz. So again here you can see that the bandwidth is higher for the optical fiber. Let us solve one example that will give us more understanding. So a transmitter antenna at the top of a tower has a height of 32 meter and the height of receiver antenna is 50 meter. What is the maximum distance between them for satisfactory communication in LOS mode, that is line of sight mode, given radius of earth is 6.4 into 10 raised to power 6 meter. We have to find the maximum distance. So we have seen in our slide that if we consider a transmitter and receiver, and if that height of transmitter is HT and the height of receiver is HR, and let's suppose R is the radius of our earth surface, our earth, right? Then maximum distance which it can the communication can takes place is equals to, so maximum distance is equals to under root of 2R HT plus under root of 2R HR. Height of transmitter, height of receiver, R is the radius of earth, right? So the distance will be equal to this, will be given by this maximum distance. Okay, this is the maximum distance. So we are given the value of the height of transmitting antenna is 32 meter, the height of receiving antenna is 50 meter, and the radius is given to us is this. So if we put these values in the formula, so the distance D will be equal to under root of 2 into 6.4 into 10 raised to power 6 plus into R into height. So height will be equal to 32 meter plus under root of 2 into 6.4 into 10 raised to power 6 into 50 meter, right? So if you take out, if you solve this square root, right? So 8 can, so this 64 can come out, and also with that there will be 10 square, and root 10 will be remaining inside. And if, in this case, if you see, it will be 8 we can take out common, and it will be 10 cube inside, and inside it will be again root 10. So if you simplify this, or if you solve this, so you take root 10 common, and if you solve this and add up, it will come out around 144 into 10 raised 100 root 10. Again, if you solve it, it will, if you convert it into a kilometer, so it will be coming out to be 45.5 kilometer. So in the options, if we see, the option A is the correct answer for this question. Moving on to the next example, it says that as the frequency increases, the absorption of ground waves by Earth's surface decreases, increases, remains the same, either A or C. So we have already seen that the distance of communication depends on the frequency and is inversely proportional to the frequency. Okay, that means if the frequency is higher, distance will be lesser. Frequency is higher, distance will be lesser, and the frequency is lesser, the distance will be higher. Now this is because the frequency increases, the absorption of the ground waves by the Earth's surface increases. Therefore, the waves cannot propagate for the long distance, right? Therefore, we can say as the frequency increases, the absorption increases. That means the range decreases, right? Therefore, the absorption will be increased as the frequency will increase. Therefore, the correct answer for this question is option B. Hello students. So in this part we have studied how and propagation of a wave takes place through communication channel. We also studied different types of communication channel, that is wireless and wireline. Okay. We also seen what is the bandwidth of signal and bandwidth of channel, right? In the next part, now we will be going to understand about and modulation and its importance, right? So stay tuned with us.